Imagine an algorithm that learns by playing 20 questions. Is the temperature above 30? Is it raining? Is there wind? Each question splits the data until you reach an answer. That's a decision tree, one of the most intuitive and powerful algorithms in machine learning. Welcome to Episode 8. Today we're covering decision trees and random forests. These are algorithms you can actually explain to your boss because they work like a flowchart. Here's a simple decision tree for predicting whether to play tennis. The root question asks about the weather outlook. If it's sunny, check the humidity. If humidity is high, don't play. If normal, play. If overcast, always play. If rainy, check the wind. Each path from root to leaf is a rule the model learned from data. How does the tree decide which question to ask first? It uses a metric called information gain based on entropy. Entropy measures how mixed or impure a group is. A group of all cats has 0 entropy. It's pure. A 50-50 mix of cats and dogs has maximum entropy. The tree picks the question that reduces entropy the most, the best split. The math is elegant. Entropy H of set S equals negative sum of P log P for each class. If a group is 100% one class, entropy is 0. If it's 50-50, entropy is 1. Information gain is the parent's entropy minus the weighted average of children's entropies. The tree greedily picks the feature that maximizes this gain. The biggest problem with decision trees is overfitting. A deep tree can memorize every training example by creating a unique path for each one. It gets 100% training accuracy, but terrible test accuracy. The solution? Pruning, limiting tree depth, requiring minimum samples per leaf, or setting a maximum number of leaves. Or better yet, use a random forest. A random forest is an ensemble of many decision trees. Each tree is trained on a random subset of the data with a random subset of features. When you need a prediction, every tree votes and the majority wins. This is called bagging. The randomness makes each tree different, and their combined wisdom is far better than any single tree. There's an even more powerful technique, gradient boosting. Instead of training trees independently, you train them sequentially. Each new tree focuses on the mistakes of the previous trees. XGBoost, LightGBM, and CatBoost are the most popular implementations. Gradient-boosted trees win more Kaggle competitions than any other algorithm. Decision trees, random forests, and gradient boosting. You now know the most practical algorithms in machine learning. Next up, support vector machines and k-nearest neighbors, algorithms that think about geometry. Subscribe, and I'll see you there.